Good afternoon. My name is Kaisa Amaral. I'm the EU Communications Lead at Agora Think Tanks. Agora Energiewende is part of Agora Think Tanks. Welcome to today's webinar, Boosting Flexibility in Distribution Systems. We are here today to discuss a topic that lies at the heart of Europe's transition to climate neutrality. To reach our climate goals, the EU needs to significantly ramp up renewable energy and electrify big parts of the economy. This means that our power grids will be under increasing pressure. A climate-neutral power system will look very different from the fossil-based system of the past. It is decentralized, it is more flexible on the supply and demand side, while market signals will play an important coordinating role. Changes will be needed, particularly at the level of distribution grids. It is crucial to find ways to use the existing infrastructure more efficiently. Flexibility such as that provided by electric vehicles, heat pumps, and home storage systems has huge potential. It can enable connecting new grid users faster and this way reduce investment needs in the long run. To gain a better understanding of the topic and how to tackle existing challenges, we contracted the consultants at DNV to carry out the work that we are presenting today. So over the next 2 hours, we will hear from the authors of this study, as well as recent Agora analysis that looks specifically at the German power system and the potential that flexibility can provide. Following these presentations, we will have a Q&A session before we move on to a panel discussion. And as you already saw, to add some interactivity to this event, we will be posting different Menti questions throughout the webinar and really look forward to getting your answers. So I hope you will enjoy the discussion. Welcome again from my part. And without further ado, I hand over to my co-moderator and colleague, Alexander Dusolt, who will give you a more deeper introduction to today's topic.
Thanks a lot, Kaisa. So I hope you can see the screen. Yeah, welcome everybody to today's webinar. My name is Alexander Dusolt. I'm a senior associate at Agora Energiewende for European energy policy. I'm very glad you joined so numerous today to listen to the findings of our 2 studies and this exciting panel we have afterwards. Also, I'm really looking forward to your questions, so please don't hesitate to use the Q&A function to post any questions you may have. And I think during my short introduction, we will already see the first Menti questions in the chat. So feel free to be active in the chat. Questions will come one after the other. So pay attention and check again because the Menti questions will update. They're then used for having a look before we enter the first question. So you're all aware of the European climate targets, reaching net zero by 2050, which means net zero emissions in all the industry sectors. For electricity, this means phasing out fossil fuels largely and replacing them with the renewables and zero emission production. On the demand side, or in the other sectors, in the buildings, industry, and the transport sector, we see that decarbonization will happen mostly via electrification. And this explains the duplication and more than duplication of the expected energy supplied and consumed by 2050. For the power sector, to enable this transition across all sectors, we will need to reach a nearly decarbonized system by 2035. So in the next decades, we will see a massive ramp up of renewables, but also a ramp up of the electricity consumption from electric vehicles, heat pumps, and industrial appliances. This is a huge challenge because all those renewables and consumption need to be connected. And some studies show that about 70% of the new renewables are connected to the distribution grids. And what does it mean for the distribution grids? So there's more electricity flowing to the distribution grids. That can already cause congestion. And then the load flow patterns change. So it's not only the top-down load flows from the high voltage grids to the low voltage grids to the consumer, but it is also changing load flow patterns. So electricity is produced on local level and dependent on basically the weather situation, load flows change accordingly and can then create congestions in the distribution grids in different locations and varying according to the weather patterns. So that's a huge change for the distribution system operators. Talking about this congestion, there are mainly two means, we'll learn more about that later, to address them. First, DSOs can invest into the grid and expand the network and strengthen the network by physical investments. And second, they can also use the flexibilities that we are adding to the system in a smart way. So all those electric cars that are charging the heating systems that are basically storing energy in the hot water tanks, so they can be used in a smart way to relieve congestions in the grid. So we need to tap this flexibility to optimize investments in the grid and also allow for the connection of the renewables that we are actually needing. On European level, the topic has been quite well tackled the last year, I would say. So we have the revision of the electricity regulation and directive, which will be hopefully approved tomorrow in the parliament. Afterwards, we need approval from the council. And so hopefully in the next few months, the law will enter into force. It requires TSOs and DSOs to publish maps with available capacities for new flexible connections. It requires governments to develop indicative national objectives for non-fossil flexibility, NRAs to report on flexibility needs. It allows NRAs to introduce performance targets to increase overall system efficiency and allows tariffs to provide locational investment signals. And also requires tariff methodologies to enable TSOs and DSOs to offer flexible connection agreements. Furthermore, the European Commission issued the EU Grids Action Plan, which requires TSOs to assess flexibility needs when planning transmission networks, the EU DSO entity to map distribution network development plans, and ACER to recommend best practice for the promotion of smart grids and network efficiency through tariff design. Yeah, and there are also other elements like the national energy and climate plans, which require also flexibility objectives, the demand response network code that lays out rules for market-based flexibility. And there's reports like the GRC DSO Observatory giving great insight into the situation of the DSOs and their challenges. Also, ACER's report on electricity tariffs is important. It shows that many EU countries already use time-of-use tariffs, but only a few have experience with dynamic time-of-use tariffs. And ACER's market monitoring report shows barriers for demand response in general. So on European level, we already have legislation in place and we have a lot of reports. And so we wondered, what does this mean for the distribution system operators and what is actually the real situation down in the field for them? We wondered, like there's 3,300 DSOs across Europe. Do they all have the same challenge or do they vary? And then which solutions are available for them to overcome the challenge, which is, as mentioned before, congestions. And we looked at barriers to implementing the solutions and then made recommendations how to overcome them. So therefore, we're very happy to work together with DNV, who took this task and used their knowledge and their network to dive deeper in those questions, and will today present the outcome of our report. And with that, I give back to Kaisa, and we'll see the outcome of the two Menti questions, I believe.
Thanks for the introduction, Alex. Indeed, we have some results from our Menti. Wow, okay, it seems like there is a very clear winner here. What is the most important to connect new generation? No, this is a new question, actually. This is not the first one, is it? We had a question about what are the... we had two questions. So what exactly the main barriers for flexibility, which I was looking at. So we also have a clear winner here. maybe unsurprisingly, money plays a big role in many people's views when it comes to the main barriers for flexibility implementation. And maybe you want to just quickly show the other one and say, okay, well, active management also raised to reach the top. So yeah, what is the most important? All of this, grid reinforcement, expansion, technical solutions, demand side flexibility. Nice, very much. Well, thank you very much for contributing to this. So I would now give the floor indeed to the consultants from DNV. We have Rogier Roobeek and Elisa Anderson, who will be presenting the key findings of this study, and you will find some of the answers also to the previous Menti questions, hopefully in these slides. So over to you.
Yes, thank you so much, Kaisa, and thank you so much also for having us today here. Indeed, we had the opportunity to work for Agora Energiewende on this project of boosting flexibility in distribution grids. So we took on the opportunity to assess the landscape, first of all, understand to what degree actually this issue of grid scarcity is a problem across different European countries. Afterwards, we looked into the different solutions after better understanding the challenge first, the solutions that could help in terms of alleviating the grid scarcity. And then afterwards, we looked into the findings and key messages that we could tell. So I'm happy to be here with the whole team today. So we have Hans de Heer on. He will actually also be part of the panel later on in today's meeting. Rogier Roobeek, that's myself. I was the project manager of this project, boosting flexibility in distribution grids. A bit on my background. So I have wide experience in market analysis, scenario development, but also especially the demand side flexibility domain. And we also have today Elisa Anderson on. And she will introduce herself when she is going to present the specific slides they will also bring to you today when it comes to the content of the actual project. So this has been the team. There's actually another team member today that is actually also has worked on this project. That's Rosario Nunes. And she is actually also available afterwards if there's any further questions to do. Yeah, so we are DNV. So for those of you who don't know us, we have been around for already 160 years, roughly 15,000 employees, many customers in international context, over 100 countries worldwide. We also have a large share of our revenue that's being spent on R&D. And we are specifically on behalf of Energy System today here. So the Energy Markets and Strategy team. So that's the advisory branch of DNV. Now, we also support flexibility or customers with flexibility on the domain of demand side flexibility through a variety of different instruments. First of all, in terms of the market design and the regulatory supports that we help with in terms of structuring the whole setup there. We also dive into with clients into the flexibility decision mechanism in terms of guiding them what works. We help in terms of implementation of flexibility options, and we actually also provide product design and verification. So that's a bit of a background in terms of who we are as DNV as a company. And with that, I would like to hand over to my colleague Elisa, who will actually walk you through the different elements of our research by first providing the contextual situation in Europe, and for which we actually also interviewed a set of DSLs. So please, Elisa.
Yeah, thank you so much, Rogier. So first of all, for those who don't know me, I'm Elisa Anderson. I'm an electricity markets and strategy consultant at DNV. My background is in energy engineering, and I previously worked in hydropower, then briefly in the European Commission, and then in ETSO at the time when the UTSO entity was forming. So it was a really interesting time. And I've been really glad to work on this project, and I'm looking forward to explaining it today. So regarding the study, DNV looked into the situation of DSOs regarding their capacity. And as Rogier said, we interviewed 7 European DSOs. We tried to select the DSOs so that they were as diverse as possible, both in terms of size as in terms of geography. And what we found was that 6 out of 7 DSOs interviewed had parts of their high voltage and medium voltage grid with insufficient network capacity, and that issue had also spread into their low voltage network. This issue was experienced both in feed and off take. This means that in feed that there was issues with connecting renewable energy, and off take meaning that there was challenges also connecting new businesses and electrified loads. And in terms of the urgency of the issue, we found that most DSOs are experiencing the issue already today, and the ones that are not in terms of timeline are expecting to experience the issue in the timeline of 2024 to 2027. Therefore, it's both quite a severe issue and quite an urgent issue. If we go to the next slide, please. There we go. So now that we understand a bit of the situation, let's see what's the challenge today in solving this situation or addressing the situation. We asked the different DSOs to rank the different drivers of grid scarcity today. We found that the first one that was ranked was permitting, and specifically the timing it took to receive the permits, being in the order of magnitude of years. The second one was financing, with some DSOs finding it challenging to access the financing needed, especially for grid reinforcements. The third one was a lack of manpower, specifically skilled manpower that could actually implement the grid reinforcements that are necessary. And the one that was ranked last was DSO coordination. And we found that that was actually not considered one of the main challenges that is being experienced today. Interestingly, there was also 3 other drivers that were mentioned by DSOs. They're listed on the right-hand side. The first one was regulatory incentives and readiness. With this being a regulated business, the regulatory incentives to encourage the investments in networks and in addressing the limitations with the network is, of course, key. The second one was supply chain issues with the high demand, especially of transformers. Norway gave a really interesting example of this, indicating that it took them 2 years to get transformers, and this has to be anticipated, and it also leads to equipment unavailability. And last but not least, several DSOs mentioned R&D and digitalization, and this is considered also to be one of the elements that can actually create quite a large impact. So now, understanding the situation that the DSOs are in terms of their network and their network scarcity and the challenges that there are in addressing this situation, what we can conclude is that there's a need for massive reinforcements. However, only with grid reinforcements. So grid reinforcements alone will not be able to address the issue, and we need alternative solutions. So if we go to the next slide. Yeah, here. So yeah, it's not an either or situation. It's a matter of needing both. There are huge capacity needs, and grid reinforcements can only address a certain amount of these needs. So in order to address the gap, we need these alternative solutions. What we asked the DSOs interview was to rank these alternative solutions that we classified in 4 main groups. They're listed there in dark blue on the left, and they were ranked in terms of their ability to make the system more flexible. The one that was ranked first was a connection and connection rights. So that's things like non-firm connection agreements, both static and dynamic. The second one is network tariffs. So time of use tariffs, mainly static and dynamic. The third one was service/market facilitation with flexibility markets and flexibility platforms, and renewable energy communities and citizen energy communities. And the fourth one that was ranked is rule-based approach, like what it's implemented at the moment in Germany. So having ranked the solutions, what we were interested then to see was in the implementation timeline in order to see whether this gap can be breached in time. Oh, if we go back one slide, there we go. So that's what we tried to do with the color coding. See if the solutions were in for any of the TSOs already at R&D, planned, if the regulation was already in place, if it was implemented, or if it was business as usual. And what we found was that there's a question whether this gap can be breached in time, taking into account the maturity of the different solutions. I think for this slide, it's also worth mentioning that it was somewhat surprising that market facilitation with flexibility markets was in third place. I think what we found was that this was because the non-firm connection agreements and network tariffs were considered to be slightly more mature, so to have a shorter implementation timeline. Therefore, they were found to have a more potential in the short term, whether market facilitation was considered to have a higher potential in the medium term. If we go to the next slide. Yeah, so if we think of the previous slide from a slightly different perspective, and we think about the TSO maturity steps in terms of the implementation of the flexibility solutions, what we found were these implementation steps. We found that all TSOs are aware of how much grid reinforcements they can implement, and they've quantified it. Also, all TSOs have quantified their network needs and have compared them with the amount of grid reinforcements that can be implemented, and therefore have identified that there's this gap and that there's a need of extra solutions to bridge this gap that we've been talking about. Also, all DSOs have started exploring these alternative solutions. However, where we see a difference between the DSOs is that not all DSOs have started quantifying the potential of flexibility solutions for the different purposes. And this is quite key because the value of these flexibility solutions actually is dependent on what they're implemented for, whether they're implemented to avoid or delay, for example, grid reinforcements, for outage management, maintenance, etc. So it's more valuable the larger the issue or the more severe the issue they're addressing. And what also we found is that only one DSO claimed to have actually quantified the potential of each of the flexibility solutions for each of the different purposes, have implemented the solution in the most optimized manner, and this DSO was Enedis. Yeah, next slide.
Thank you so much, Elisa. So now that we have told you the context, the challenge, the drivers, as well as the solutions, we would like to infer from this the findings and key messages of this study. So I think, first of all, we should really conclude that flexibility solutions are really at the heart of this and could really be part of the solution also in terms of alleviating grid scarcity. So now there's four key players here that are important to consider. So let's start with the market parties. They're actually having the challenge of experiencing uncertainty as a barrier to participate in demand-side flexibility, because there is simply too much uncertainty in terms of using or actually bring these solutions to the markets. Secondly, we actually also see that the DSOs actually seem to await further guidance from the regulatory side in terms of starting up the implementation of these demand-side flexibility solutions. Thirdly, we actually also see that the customers have sometimes difficulty in participating in these solutions, and that's actually for a variety of reasons. And finally, we actually also see there's a bit of this waiting game between the NRAs and the DSOs in terms of getting these solutions at play. So that brings us actually to the second set of findings and key messages, and that is actually the recommendations that we defined on the basis of this study. So we defined the recommendations, first of all, for the NRAs, so the National Regulatory Authorities. So we believe it's very important that DSOs are sufficiently incentivized actually to implement the further deployment of these flexibility solutions. That will be the first recommendations towards NRAs. Secondly, we also believe it's very important that the DSOs are encouraged and fairly compensated for this. Thirdly, we believe it's very important that actually the regulatory frameworks are in place and that are actually also rightly developed also on the basis of this new European law that is upcoming. Fourthly, we actually also believe it's very important that the speedy, indeed, transposition of the European regulations on the basis of the EU Electricity Market Regulation and Directive are actually also firmly in place. And finally, we actually also recommend that it's important to stimulate customers further to unlock their flexibility. Now, after having identified the recommendations for the NRAs, we also identified a set of recommendations for the DSOs. So that brings us actually to the second set, and that the first one is we believe it's very important that the DSOs start quantifying the capacity scarcity. So on the basis of these interviews, we noticed that not all DSOs have very good visibility in terms of what the grid capacity scarcity actually is in their grids. Secondly, we actually believe it's very important that the DSOs start quantifying the potential of these solutions, because only when you have quantified what these solutions could mean, then you could actually also start implementing them and understand what they eventually could contribute. Thirdly, we actually also believe it's important for DSOs to formulate or start formulating a strategy in order to implement these solutions. Fourthly, we also believe it's important that the DSOs actually have a set of solutions so that they can actually easily pick and choose which solutions are fit for which conditions. And finally, we also believe it's important that they conduct a self-assessment, since actually applying these flexibility solutions also requires a wider set of capabilities within the organization. So with that, I think we can conclude our part of the presentation of today. Again, we would like to thank you very much for the opportunity to present today. Of course, we'll also still be on the panel later today with Hans de Heer. And here are also our contact details should you need any questions or should you have any questions which you would like to support from us. Thank you so much. And with that, I think I can hand over to Kaisa again.
Many thanks for the presentation. Indeed, quite sobering messages from there when it comes to the status of things on the power grid situation, but also, I would say, very clear calls to action, so to say, to the different actors on how we can improve the situation. Okay, let's see if I can get the many questions now in the correct order in my head. Maxi has posted 2 more questions, and we will get the results shortly on the screen.
Can you quickly stop sharing?
Okay, which share of end users you estimate are interested in dynamic tariffs? Let's see if the numbers are still living. But I would take from this that we're not very confident in, how much interest there is. It's only 0 to 20%. Seem to be the winner here. How much fuel costs could potentially be saved through demand response in Germany? Nice. We seem to be taking the middle alternative here. Good. Well, while those numbers still slightly evolve on the screen, I would like to now hand over to Katrin Schaber, who works at Agora Energiewende, and you will find that she has a very interesting presentation looking specifically indeed in the German situation and the dynamic time of use tariffs and their potential in Germany. Please go ahead, Katrin.
Okay. Thank you so much, Kaisa, and good afternoon, everyone. It's a pleasure for me to be here. And my name is Katrin Schaber. I've been external project lead on this project I will present in a bit, together with my colleague Mareike Herrndorf, who's also in the back and will answer questions in the Q&A. And now I will start sharing my screen. There we go. I hope you can see my screen in a second. No. So the study I'm talking about is called Utilizing Household-Related Flexibilities. And we published it last year. And what we did is that we examined dynamic tariffs and how they affect electric vehicles, heat pumps, and home storage systems in Germany. When doing so, we looked a bit ahead. So we looked until 2035. So this is a bit different from the study that we've just seen before. And if you look at 2035 and if you look at what will happen on the household level, you will see that there will be tremendous changes. So we expect new flexible assets to come into the system on the demand side, and those will add important flexibility potential. So in 2035, as you can see here on the left-hand side, total capacity of charging, heat pumps, and home storages will largely exceed the current maximum load. And we did perform a bottom-up simulation of the households to study the behavior. And the results show behavior of the households loads. And the results show that with dynamic tariffs, we can shift 100 terawatt hours of load in Germany, which is quite substantial. Keep in mind that German current consumption of electricity is around 500 terawatt hours. And this, of course, can help substantially to integrate wind and solar energy better into the system. So, as I said, we did detailed simulation. Who did the simulation in this case? Our partner here was a well-known German research institute, Forschungsstelle für Energiewirtschaft, who did bottom-up simulations of the households on single building level, and importantly, also of the low-voltage grid in Germany. And at the same time, we had an advisory group that accompanied the study throughout the process. So, as I said earlier, we looked at dynamic tariffs. And we did so in 4 scenarios. So we analyzed 4 scenarios for types of dynamic tariffs. And they differ to the extent to which they take into account the wholesale price and the grid utilization. So here I'm adding a new level of flexibility application, which is the wholesale market. Before, we've only been talking about the grid, and now we look at the wholesale market at the same time. Okay, so the four scenarios we will look at is the first called low flex, where basically we look at in Germany. So we have a constant procurement price, constant grid fees, and so there's no incentive whatsoever for German consumers to shift load. The second scenario is called flex, where we pass on the wholesale electricity price to the households, but the grid fees remain constant. And then we examine on top of that 2 types of use grid fees, where we add to the wholesale price a grid fee that varies in time. And the first version is that the grid fees varies in a static manner. That means that peak and off-peak are determined in advance, so a year ahead and for large areas. And the second version is the dynamic time of use grid fees, where we have peak and off-peak times being defined at short notice, a day ahead, and for smaller areas. And again, I would like to highlight that we have now basically 2 incentives that are combined. So we have the incentive from the wholesale electricity market and the incentive from the grid. So basically, we're using flexibility for the market and the grid, depending whether we have this grid fee, yes or no. When looking at the result, I would like to first of all focus on the effect from the market perspective. So again, if we shift load 2 times with low wholesale prices, this will be times with a lot of wind and solar energy being available. And if we shift it away from times with high prices, we will shift load away from times with no or with low renewable availability. This means we can reduce the usage of other flexibility options. And this comes with costs. And you already did an estimate on how many costs we can save. So I can say your guess of 500 million was a bit too low. We can save almost 4 billion a year. And I will explain to you why. So here on the left-hand side, we see the costs for providing flexibility in a world where there's no demand-side flexibility on the households. So all flexibility is provided by conventional means, being gas power plants, hydrogen power plants, and battery storages. And this comes at annual costs of more than 5 billion euros a year for the year 2035. While if we would activate the demand-side flexibility, we will need to expand the grid a bit. We will see more about this in the next slide. And this comes at annual costs of less than 1 billion a year. So in total, we save 4.8 billion in 2035, thanks to those dynamic tariffs by activating the demand-side flexibility. Now, what happens on the grid side? We've heard earlier that distribution grids are under stress. There is a need to expand them. And of course, we see the same thing. So already in the low flex scenario here on the left-hand side, we see that there's a need for grid expansion until 2035. So here we have basically no load shifting, but this amount of investment that we need, 7 billion euros until 35, are needed to integrate electric vehicles and heat pumps, basically. Now, if we add price incentives from the wholesale market, if we pass on one and the same wholesale price to every single building, the loads will synchronize. And this, as a consequence, leads to an increase of grid utilization and increase of grid investment needs. So we see here in our findings that we need 10 billion more investment in distribution low voltage grids until 35 because of using flexibility for the market. So using flexibility for the market causes issues in the grid. But if you add time of use tariffs on top of it, you can alleviate the problem. And if you go to the last column here in our plot, you see that with dynamic use tariffs, we can reduce the additional grid expansion by about half to about the half of the level. And they would actually combine nicely using flexibility more for the market and the grid. While if we look at the blue column where we looked at the static time of use grid fees, we see that those grid fees are not precise enough actually to alleviate the grid congestion. And therewith, as you can see, the grid investment stays at about the same level. But of course, this can be a good step towards realizing dynamic time of use tariffs. However, we can reduce grid expansion with time of use, with dynamic time of use grid fees. But however, of course, we still need to expand the grid. And I want to give you a bit of put a bit into perspective the amount of grid expansion that we need. So in this plot, what we see here is, first of all, the grid stock that we have in blue. So that's the kilometers of low voltage domestic grid. And you see the evolution that we found in our simulations, where you see that in 2035, if we would pass on the wholesale electricity price to all consumers, but not change grid fees, we would need quite important grid expansion. And if we compare this to the historic trends, to the historic speed that we managed in Germany to expand the low voltage grid, this will be a big, big challenge. If we add dynamic grid fees on top, the grid expansions that result actually remain feasible. So this is a good possibility to make things happen, to use the demand side flexibility while not stressing the grid too much. So after I've shown you some key results of our studies, I would like to sum up at this point. And of course, I'm looking forward to your questions later on. So as we've seen, electric vehicles, heat pumps, and home storages are going to be added at the household level. And if we incentivize them with dynamic tariffs, they can provide 100 terawatt hours of flexibilities in 2035 to the German power system, and therewith save almost 5 billion euros in that year. in system costs. If we combine those dynamic tariffs with if we have dynamic tariffs which combine wholesale prices and dynamic time of use grid fees, we can activate the household flexibility while the need for grid expansion is reduced. So this is a clever combination. The third point on the summary slide here is something that I have not touched upon yet. Maybe we will see it in the discussion. But it's important to mention that in Germany now we have an ongoing digitization of the distribution grid, and that makes the introduction of those dynamic tariffs possible and very timely. So it's a good chance to start now. And last but not least, consumers can benefit from those dynamic tariffs. That means with dynamic tariffs, their electricity bills will be reduced, and also they will become active players to contribute in the energy transition. And in the Menti questions before, you estimated it's only 20% that will be happy to participate. Now, if you think about a world in 2035 where you may own an electric vehicle or a heat pump, maybe your readiness to participate in dynamic tariffs will increase. The assumption that we have here in our study is that 50% of German households do participate in this tariff scheme. Okay. That's it from my side, and I would like to hand back to Kaisa.
Thank you also for this very exciting presentation. Without further ado, I will go into the Q&A session because we have nice number of questions here. First of all, there were a couple of questions that are addressed to our consultants. One of them maybe is a little clarifying question, so I will ask to Elisa first. I did not understand your point that one DSO has optimized the use of flex. Then Steve Heinen is referring to the step 6 on slide 8. Could you elaborate what you mean here by optimization?
Yeah. So this was the example for Enedis. So what Enedis has done is quantified the potential of flexibility for all of the different purposes for which flexibility can be implemented. So that's things like outage management, avoided of grid reinforcements, higher efficiency of the grid, maintenance, etc. And they've compared also because different flexibility solutions can be implemented for the same purposes. So then they've seen which one is more technically feasible and economically feasible. For the ones where there's doubts, there's also quite some R&D done, and it's all quite clearly explained in their development plan from last year. So yeah, I would encourage people also to have a look at that. There's also further detail on the Enedis specific case in the expanded report. Now here we've only explained a brief summary, but I'd also encourage people to read the whole thing.
Thank you. I hope that clarifies it. And the second question on the DNV presentation, maybe Roger wants to take this. Can you give some more details about the DSOs that you interviewed, especially in the case of Germany? It would be interesting if the respondees are big multinationals or small communal Stadtwerke.
Yeah, of course. So yeah, it's also embedded in the report. So we did a variety of countries here. So 7 in total. We actually also had a counterexample here included being Norway in order to understand also a bit the outside European Union perspective. But in the case of Germany, that was E.ON.
Perfect. Then we have a question on Katrin's presentation. How dynamic should the grid fees be? Should they be individually calculated per household / low voltage node / DSO area?
Thank you for that question. So the way we designed the dynamic grid fees here was that they were calculated basically day ahead, or you can think of a process that does this. And geographically, that would be per low voltage node per transformer. on the way there, of course, I mean, this is sort of an ideal setup, but on the way there can be steps, and certainly the geographical differentiation is one of the later steps that would be necessary, according to our assessment, in order to make this happen.
Excellent. And I actually have two more questions to you, Katrin. So the next one goes, smart meters are a prerequisite for the billing of dynamic grid tariffs. Now, is the ramp up in Germany sufficiently fast to achieve the results that you presented?
Yeah, that's a very good and very common question in this context. And as I said in my results, we have a push now in German distribution grids. So we have an increasing need for digitization. We have new laws, we have new requisites that actually do speed up the process. And we were actually quite surprised from the discussion in our advisory group, where we discussed with the DSOs, and they said, hey, actually, we're gonna be on track. This should be okay. As I said, we are looking with the assumptions that we have in our studies say that we have 50% of households that participate in dynamic tariffs, and those shares should be met according to our advisory board by 2035.
Good, thank you for that, and I hope that also clarifies. And finally, last question for you now, as far as I can see, why did fully dynamic TOU not result in the most potential cost saving? Surely those tariffs best incentivize the best time to consume, or not?
Yeah, that's the question. I guess the answer to this question is what you use the flexibility for. So in our study, the first purpose of using flexibility basically is to help the national market, is to balance out national balance between supply and demand. So shifting load from low renewable availability to high renewable availability times. And in order to do so, you hand over the wholesale electricity price to the consumers. And if you send the same signal to everyone, everybody will respond in the same way. So the load will be synchronized and the load on the distribution grid increases. So, and then from here, from this high point, you can start trying to make the system a bit better. And so basically we showed that when you use dynamic time of use tariffs, that is the best option from the ones that we looked at to reduce the grid load back down a bit, sort of, but we cannot get back to the level without any demand side incentives.
Thank you. I actually have one more question that has just come in, and since we are very well on time, I will just go ahead and shoot. So did the analysis take into account that regionally and temporarily varying price incentives also influence investment decisions? And thus the placement of DER, which I have to acknowledge, I do not know what it means.
I'm not sure either. Demand response, I guess.
Distributed energy resources.
Oh, thank you. Thank you. Yes, of course. Yeah, thank you. Sorry. Of course, yes, we did include own generation from solar PV, and that was taken into account in the individual simulation of every building type that was looked at.
With that, I want to say that we can close this FAQ session. We will have another one later on. So thank you so much for the three of you for the very good presentations and taking all these questions as well. I would now like to hand over again to Alexander, who will take over the moderation of our panel discussion.
Thank you very much, Kaisa. And Derek, thank you very much for the speakers and already the questions you had. And I think before we are starting the panel, it would be nice to look at the Menti slides. I'm not sure, Maxi, if you can already look into the first one while participants answer the second question. Is that somehow possible? So the first question we thought would be interesting, what is your situation in terms of dynamic electricity tariffs? Do you already have a dynamic tariff? Are you interested? Are you not interested? Or don't you have flexibility and live in an apartment like so many of us? And yeah, we already see Many are interested. Also, many don't have flexibility, and maybe not everybody has an EV in future, and not everybody has its own heat pump with hot water storage. So then it's becoming difficult. And some of them are front runners, and they already have dynamic electricity tariffs. So that's also great to hear. And I also understand those who are not interested, as there are still burdens, and I think we'll talk later a bit about it. In the end, it has to be easy, and people have to save money. And if one of the two doesn't apply, then people may not be interested. And at the moment, it's really still in the early beginning in the market uptake phase. Maxi, can we look at the second question? So who should act first to increase flexibility volumes? So we have seen before the vicious circle from Rogier. All the parties acting, waiting for the others to act. And we thought the Commission, member states, DSOs, market participants, and grid users may be the ones who should start first. And the outcome is here very clear. So apparently something should happen on the member state level and on the NRA level. And also on the DSO level now. Great. So let's move on. I'd like to introduce the panelists and then quickly introduce the panel with my takeaways from the study before we start into the questions I've prepared. So please turn on your cameras when I introduce you. So we have Santiago Gallego Amores. He's a networks regulation manager at IDE, the DSO of Iberdrola. I just wave Santiago so people know who you are. Then we have Judith Kreis, international electricity expert from the Hungarian Energy and Public Utility Regulatory Authority. And Judith, I learned you're also a vice chair of the CER working group on distributed flexibility. And apologies to all of you for not pronouncing your names correctly. We have Naomi Chevillard from Solar Power Europe. She's a head of regulatory affairs there. And we have Hans de Heer from DNV. He's a principal consultant and business lead. Thank you for joining. I quickly take over the screen to share my key learnings from the work. So from the material we have now seen and the interesting insights, I took away that there is a real challenge in the distribution grids. Congestions in distribution grids are likely to appear or already appear and hinder already the integration of renewable electricity generation and the switch to electric appliances. And this puts a risk at meeting our 2030, 40, and then 50 climate and renewable targets. So first of all, we need to assess the available and future flexibility potential in this distribution grids. We saw already many measures are taking place or are required on the European level, but we think also on the DSO level, this is needed. Also DSOs, on the DSO level, we need improved grid observability to identify the most suitable congestion management solutions tailored to the needs of the system. So we have those two recommended solutions, but of course, among 3,300 DSOs, the situation differs. And you need to look at the whole variety of solutions to find the one that's fitting you. And on the specific solutions, I took away that dynamic non-firm grid connection agreements can quickly relieve congested grid elements and activate significant amounts of flexibility. So for the DSOs, it may be a quick win, basically, to talk to larger feed-in generators or larger industrial consumers, maybe the new ones to be connected and offer them a non-firm connection agreement. Could be a quick win. And then in the longer term or medium longer term, this could be a switch to dynamic time of use tariffs to activate larger volumes of flexibility, including from households, and allow/require automated and targeted solutions to relieve grid constraints. So there, of course, you can reach more consumers, but it requires that you have automation in place. You know where your congestion is, so good observability. You can then design a tariff on top of that. You also need to learn what's the price difference, and Katrin gave a great example. They studied how that could work. You have to know the price difference that you need to put so that consumers react, and the consumers need to be able to react. So point towards smart meters. They need to have smart meters and the energy management systems to be able to react to those signals. And so we can relieve the constraints. So far from my side, but now we really want to hear more from you. And the first round would be on the challenges that you're experiencing already from your professional background and experience. So how do you see the challenge ahead, and what's the urgency from your perspective on the topic? And Santiago, could we start with you with the DSO's perspective?
Okay, thank you, Alexander. Good afternoon, everybody, and thanks. For the invitation to this webinar. Especially because it would be strange to have a webinar about flexibility on distribution grids and not having ideas on the panel. So I think that's my role here to voice the insights from the industry. And yes, congratulations for the study. To the DNV and Agora teams, because I think you're reflecting in the study reflects very well. The feeling of DSOs and the urgency that you were referring to in your words, and I think it's very clear to us that we need to use from the DSO perspective. We need to use all the tools that we can utilize in the moment. Of course, not all of them are available at this moment, but I think that we have to be aware of the urgency of the moment, and with this amount. This great amount of renewables trying to connect to the grid, and also the increase of electricity demand from demand side. So, as you were pointing out, the network tariffs, flexible connection agreements, and market-based procurement, all of them are valid tools that we should use in the next coming years for having specific solutions for solving the congestion and voltage problem that we can have in our grids. Of course, there is not a silver bullet for all of them, but just a combination of them, and probably a tailor-made specific solution for every situation. So yeah, I think it's more or less the problem that we are facing. Answering to your question, and we think that as far as we have this toolbox in place, we can start thinking of solving the problems in a different way. So that will be my first statement on the panel. Thanks.
Thank you. Very interesting. Then second, I'd like to hear a grid user's view, and from Naomi, I think you have basically twofold experience. One's connecting solar and asking DSOs for connections, but second also for the households that are reacting maybe to time of use tariffs and can optimize behind the meter. Over to you.
Yes, thanks a lot, Alexander, and thanks to Agora for having me on this webinar. It's really good that you highlight the potential of building flexibility, because when we see the discussion in Brussels, it's not fully, it's not discussed enough from our perspective. Politically, it's not present enough compared to the importance it has industrially or technically. Yes, I think your question was about the urgency. I absolutely share that feeling. I think there's an urgency on the ground, but also a political urgency, if I may say so. I think it was in 2021, we initiated a report in Solar Power Europe that you can see here. you can't see because it's it's blurred, but it's called Grid Planning and Grid Connection. And it's a report for which we wanted to look at the provisions on grid planning and grid connections in the market design and check if they were implementing on the ground, because it was a complete black box for us, to which extent the idea in the market design were translating into results on the ground, and whether the situation was good or not. And the feedback that we had is exactly what you showed, that either there's a problem already, or there's a lack of preparedness and there will be an issue before 2030. And just to give you some examples, so we have issues with congestions that block grid connections of new solar assets. The typical case is the Netherlands now with the map with congested areas. In Denmark as well, you can still connect, but the grid connection tariff has been changed, and so it's prohibitive to connect new assets. But even when you're connected, we have more and more countries that know that acknowledge important episodes of curtailment. Just last month, Poland activated curtailment of renewables 3 times in the month at a quite large scale. But I think there's one other emergency, which is a political emergency, because again, the report was triggered by the rules of the clean energy package, which are actually, it was already an emergency in 2016, 2018. We already knew what was coming. So we designed rules, and we designed quite good rules. But what we found out in our report is that they're not implemented on the ground because DSOs are so decentralized, because there are so many different companies. And so I think the other emergency that I would see is also to think, okay, we had those good rules that have not been implemented on the ground. We have a new political cycle restarting. What can we do to change the situation? Maybe provide the tools to DSOs to implement, maybe share good practices, etc. So, two emergencies that I see.
Thanks a lot, Naomi. Very helpful to get this perspective. So we also have the regulators here, and Judith, I'm sure you also have a view on the situation currently and the urgency of the challenge.
Yes, thank you. Thank you for having me. Thank you for the presentation and the study. It is really the hottest topic, as is also recognized by the Commission in the Grid Action Plan, in the electricity market design, in the demand response network code. So the regulators and the legislators are aware of the pressing nature of this problem. And also in Hungary, we are in need of boosting our flexibility and also in the process. Just as Naomi mentioned, the capacity to connect new generation to the grid, especially solar, is quite challenging in Hungary as well, because just this year we reached 6 gigawatts of installed capacity, whereas our daily peaks around 5,500. So it's already surpassing. And I think you referred in your presentation to the National Energy and Climate Plans. Our goal is for 2030, 12 gigawatts. So this challenge will just increase in scale, but we are also on the way to tackle this. For example, this is the week when one of our DSOs flexibility platform will go live by calculating capacity and congestion on the grid. So it's a nice milestone to present here. And also in February, we just closed the tender for adding new grid scale storage to the system, mainly focusing on AFRR markets, but hopefully giving more flexibility to the distribution grid as well. Yes, and we are in the middle of reshaping our connection capacity allocation rules, just for the reasons that Naomi mentioned. So I hope that we are not the bad guys, contrary to what's maybe suggested in the report. but we've seen also great examples of DSOs having the initiative and having proposals and having cooperation and good coordination with us. So that's very important. Maybe I don't like to formulate key messages in my introduction, but coordination and cooperation among stakeholders would be paving the way for us, in my view. Thank you.
Thank you very much, Judith. And Hans, we already saw on the challenges, we saw already the outcomes of the study, but I thought maybe you still want to come in and share some further views or examples, knowing that you're busy around Europe and have probably many examples. You could give some insights on. So,
yeah, sure. Thank you, Alexander. Happy to do so. Of course, interesting to state that these concepts, these solutions, demand-side flexibility solutions have been tested for, I would say, decades already in all those smart grid trials that we have seen around Europe, where the DSOs often are in the lead together with many other actors. I would say traditionally those smart grids have always been presented as let's say, an alternative for grid reinforcements, but more in an, let's say, economic efficiency sense. So it would be more affordable to use flexibility rather than just expand the grid. But that until now, I must say, was not a strong driver for DSOs to implement those solutions. Or maybe market parties to offer them. Again, it's about this ecosystem. But that has now rapidly changed the last years. And as explained by Elisa, but also by other panelists, we now see that, DSOs simply cannot keep up with the pace of the energy transition, especially when it comes to renewables, connecting renewables, but also when it comes already to the electrification of demand, batteries. We see, I would say, all around Europe, large issues already today. And there was already mentioning of the Netherlands as an example. I think that only serves as an example because there is a bit more transparency, I would say, in the Netherlands on those issues compared to some other countries. Because we see in almost every country, and there were some examples given already, that there are already waiting queues for especially renewables, for batteries, but also for demand to be connected. And that's not always visible, but it's there. So in that sense, yes, alternatives are needed. Urgency is there. And it's not even, I would say, a temporary solution. Yeah, what is temporary? Yeah, but even if you do reinforce the grid, which is in the end the ultimate solution, and you don't need the flexibility at that location, then it will move to another location. Problems will emerge at other locations, and then you will need the solutions there. So yes, they are needed. It's not a matter of selecting which you can use and which you can't, because you probably need almost all of them as on both technical and market-based solutions. But we also realize that despite maybe those 2 decades of trialing, the solutions, they're not solutions really yet. There are concepts. So we don't see solutions that you can simply plug and play that will bring you all the transmission distribution capacity that you need, or the non-wires alternatives that you need. All those 4 categories of solutions that are discussed in our report, they all have their pros and cons. They all need to be further, detailed. I wouldn't say trialed, but trialed in real life, and enhanced in real life. And often their potential is not even known to the DSOs, and also something that was addressed. So we also have to be careful that, although we're talking about, the time, that is the main issue of those grid expansions. So the demand grows faster than the grid can be expanded. Also, those solutions take time to implement and to really be functional. And actually, in hindsight, those solutions should have already been there, but that you can say that, but that's it doesn't help us any further. But it does also create urgency for those flexible solutions that even if you don't need them today, surely you will need them tomorrow, and it takes more than one day to have them up and running. So that's my main feedback on this point.
Thank you very much. I find this first round already very exciting with the different views. For the second question, I'd like to ask Santiago and Hans first on technical solutions. Like the study really focused on demand response solutions, but we noted that these also have technical solutions. Like you have a congestion, you can enhance the grid, you can implement technical solutions, and you can do demand response. So the question, do you already have experience with technical solutions to enhance the observability and controllability of the grid? Maybe the first part of the question. And we also talked about flexibility assessments, like this idea of DSOs doing flexibility assessments, assessing the need, what already is required on European level. Do you have experience with that? And Santiago, if you want to start again, and then Hans.
Yeah, sure. And I agree with what Hans said. I mean, this is not new. I mean, the tools that we are describing here are not new. What is new is that we need, I mean, overall, we are very close to have the regulatory framework to use them. In the past, what we used, of course, as complementary to the grid reformer was the technical solution you were mentioning, Alexander. This is not new. This was also called somehow the internal flexibility. I mean, the way we can operate our grids in a way to avoid the specific problems that we can have in certain hours of a day or certain days of a year. That was something that is a part of our tasks. Like operating the grid in a more dynamic way, or using, some dynamic line rating or things like that. This technical solution that you all know, they were always in place. What has changed, or the game changer, is that we have, now smart grids. Smart grids with smart meters, and the way that we can have a very good observability and also control of the grid has changed everything. Now it's an open door to use, for example, demand response, and to have this market-based solution that we were not able to have in the past, not only because the regulatory framework was not there, but also because it was not part of our technical solutions. We didn't have the observability of the grid. We were not aware where this congestion were happening. In a predictive way. We now can have this, can very precisely. One thing, in this discussion, one thing we have to consider, and also as going back to what Hans said about definitive solutions and that it's the usual the grid reformers, is that you can imagine that distribution grid is now facing a big problem. Or a big challenge, not a problem, because it's also an opportunity to decentralize energy. That is something that it's a high level policy of the European Commission. But imagine that we used to have the energy coming from the transmission grid, and now we are having it, every day more from our grids. It's produced and generated in our grid. So this is changing the way we have to manage it. The low voltage grid were, just one direction managed, because the was the end of the line. But now it's not the end of the line. So this having a very good impact, a very great impact on our grids, will pose us the problem of how to manage the grid this way. And other thing, imagine that all these cars that have been using a petrol station for decades, and now they are going to use the low voltage grids to use this amount, this great amount of energy coming from the petrol to electricity. So you have to think in vast amounts of electricity being managed differently. So this is why I'm talking about needing everything. The traditional investment, of course, in a big part, but also all the tools that we can use and that can complement sometimes in a provisional way, but sometimes also for solving the problems in a more structural way. Thanks.
Thank you very much. Very, very interesting to see that you actually did the technical solutions, and the world is changing, and you need to keep up on different fronts. Hans, you want to say something on the technical solutions and how far you find these also applying them already? What other picture do you have from the Spanish picture?
Yeah, sure. And well, as you said, it was not the core of this study, but I would like to reflect on technical solutions, because I think, and it's also our experience that we have with some of the DSOs international, that there is also a room within technical solutions to create more grid capacity, or virtual grid capacity, or at least connect more customers in the end. And yes, I agree that some of those technical solutions are already applied, like dynamic asset rating, but we also think it can be further stressed. So it can be, and often dynamic asset rating is implemented in a quite static way. We don't want to go into all much details, but we think there is, on the technical side, also room for improvement. Another example is that, as you know, especially higher levels of the distribution grid have redundancy, and they are and they have this no single point of failure and -1 criteria, where and that is often implemented just by redundancy in grid assets. You can use today that redundancy just for transporting more electricity. Of course, you need other ways to meet those N-1 requirements, and there again, demand-side flexibility could play a role. So also in those technical solutions, we see there is further optimization possible, and because it's possible, we think it's even needed. There we also see it's also part of the culture, because there is at least a theoretical chance that reliability is affected. It's something that can be managed, but yes, as a DSO, you should be willing to explore that and to take that risk. In the end, we think that it's not only about reliability anymore, it's also about sustainability. You have to find the right balance between connecting more low carbon technologies, renewables, against reliability, and not seeing that as the only criterion. So that is what we see on technical solutions, that there is room for improvement. We see that more, I would say, on transmission level. There we see some DSOs already taking further steps in that direction. DSOs are today, this at least personal opinion, somewhat reluctant to explore the full options of the technical solutions that are out there. Realizing that they also introduce complexity, and that's also something we typically want to avoid in critical infrastructures. But I don't think there is now choice anymore, that you have to accept somewhat more complexity to be able to connect more customers.
Yeah, very clear and very nuanced views. Thank you both very much. And I'm sure Naomi and Julie could also contribute. I think we want to move on to get to the core of the debate and talk about the demand response solutions. You saw before, we have those recommended solutions, the dynamic time of use tariffs and dynamic non-firm connection agreements, acknowledging that these also work on the others. And acknowledging that there's also flexibility markets. So I would be interested in your views on this prioritization. Do you agree on that? And what does it mean for your association or your consumers? And starting with Naomi, solar power. Is it the dynamic connection agreements are most relevant for you, and how does it relate to other flexibilities your clients actually could provide? So interested in your views. Thank you.
Yes, thanks for the question. I agree with what has been said just before. So, yeah, Solar Power Europe has been supporting the idea of non-firm, first non-firm. So it means any connection agreement where you don't have a firm capacity for your peak consumption or production. Because we see that we're ourselves impacted by congestions, so we need to find ways to alleviate the pressure on the grids from consumers and from producers. But also we see this kind of agreements as, in a way, a simple solution. I think Hans mentioned the fact that we need time to introduce those solutions. We need simple, easy solutions to trigger flexibility, and we see those connection agreements as, in a way, simple tools to introduce flexibility. It's also simpler for the consumer to understand. It's relatively straightforward to think my solar panel is going to charge my battery and my heat pump or my electric vehicle. Then there is a different nuance in what a non-firm grid connection agreement is. There is what we call the static non-firm grid connection agreement, where you're peaked at you have a cap on the peak production, peak consumption that stays the same over the timeline of, over the day, for example. And here we think it's a tool that can be used as a permanent tool, not only when there is a delay in construction the grid, but also as a permanent tool to lower the pressure on the grid. Because then it encourages self-consumption and prosumer type of contracts. Then you're right, there is another type of contract where it's what we call it a dynamic non-firm grid connection agreements, where you're capped at certain hours of the day when there is a congestion in the grid. We also think it could be an interesting type of contract. So having the DSO being allowed to curtail the consumer or to cut the consumers when there are congestions. But then it's always a question of under which condition. So first, it's if you're in an area that's congested. Second, it's something that should happen after markets, so local flexibility markets have run. There are procedures that we could use to make that happen. And third, I think we need to put a certain limit to those kind of contracts. For example, if you are curtailed a certain number of hours over the year under the dynamic contract, you receive a compensation as a consumer. So it's a compensation for the consumer, but it's also a signal for the DSO that there is still congestions and that there is still a cost of not investing in the grid and solving the congestion, the basis congestion.
Great, very clear. Maybe let's move on with Judith.
Yeah, I'm so keen. Really.
Great, you directly want to come in. Perfect.
Just really advertising. CER, which is the Council of European Energy Regulators, we are very actively involved in the topic of non-firm, or as we like to refer to them, alternative connection agreements and the procurement of flexibility. And we like to classify the flexibility procurement in 4 categories, as is reflected also in DNV's report: market-based, which is, by the way, preferred by the Electricity Market Directive as well. So this should be the default option, and only by way of derogation by the NRA can DSS procure it in other ways. Then tariffs, then rules-based mechanisms, what is redispatched 2.0, and flexible connection agreements, which will also be defined in the tomorrow voted on EMD proposal. So there are quite many. This classification of dynamic static is one way to look at them, but there are certainly very many forms in how the agreements that do not grant unlimited access within the capacity that was allocated to the connection point. So everything that has not granted unlimited capacity for the connection point is non-firm. Non-firm would be an use it or lose it clause. Non-firm would be a fully flexible connection agreement, which is similar to active network management. You get what's in the grid. Nothing is fixed. There are non-firm connection agreements that are divided by a firm proportion and a non-firm proportion. Also, the curtailment possibility is allocated to a certain amount of time units, like 80% firm, 20% curtailable of the time. So there are a very wide range of variety. And that, of course, depends on who is the other party the DSO is offering it or requesting from the DSO, and what is their capability, the behavioral flexibility. So these are very nice tools, and what they're very appealing is their implementation timeline is very short. So if the legislative framework is in place, then or at least not too limiting, then they can be applied by the DSOs upfront. But as in the CER paper, I've been part of the drafting team called Alternative Connection Agreement, contains in their conclusions these agreements harbor some dangers for the flexibility market, which is the preferred way based on European legislation of how DSOs should procure flexibility, which the first is locking in flexibility from either generation or demand. The second is for the DSO, it's a nice and simple, a quick fix solution, and for the DSO it seems to be free, but it's not free for the entity that is contracting non-firm, because they don't receive the market, the possible or potential market price for their flexibility, and they don't really know what they lose, because the rationale for the non-firm connection agreement for the connecting party is quicker access for a lower connection fee, connection charge. But we will see how these how the national framework of these agreements will develop. Also, there is a little mental note that the demand response network code will touch upon these agreements as well, insofar as they might limit market-based flexibility procurement. I could go on.
And I have already many follow-up questions, but let's make the first round complete. So give everybody the chance to comment on the demand response solutions. Hans, you want to go next, and then lastly Santiago?
Yeah, sure. I was also a bit surprised by the order that came out, at least how I interpreted the question was, well, what do you consider the most, which solution provides the most value, which creates the most capacity to connect more customers? And of course, that was difficult to answer because hardly any of the DSOs did any quantification on that. So I interpret their answer more as which is the easiest to implement and the shortest time, as I think also Naomi mentioned. And then I recognize, yes, indeed, those non-firm connection agreements, they're relatively easy. Of course, they need a regulatory framework as well, but we see them emerging in many countries. So do I know? No, of course, because you need to do the quantification before you can judge. And we see all those solutions have their drawbacks, have their challenges, like flexibility markets. Those few ones that are out there in the business as usual environment, mainly, I would say, Great Britain, Netherlands, France. I think they suffer from low participation, especially on the demand side. It's very difficult to attract customers, end users in those markets. Doesn't mean it cannot be made to work, but today that is a problem, and that is something that has to be overcome. So there are challenges on all those solutions. For the non-firm, I think this was already explained by Judith. One of the main drawbacks is that it's not really market-based. Of course, it can be voluntary, but there's no real price exploration behind it. So how, whatever reduction on grid fee you allow, and then it's probably mainly relevant for demand, as generation typically don't pay fees. How do you know you're not overcompensating them or undercompensating them? That is a big challenge. So it's probably not the ideal outcome. It would be nice if it could be, let's say, a first step and can be migrated on the longer run to a flexibility market and mechanism that is fully market-based.
Thank you very much. And Santiago, your views on the different options.
Yes, not much more to add, really, because I think that Judith and Hans explained very well. I'm really happy to hear what Judith said, because not only because the regulators are aware of the complexity of the issue. It's not like now using the flexibility agreements, non-firm connection agreements for everything. It's good to know that the complexity is on top of the agenda of the Commission and also the regulators, and that we have to be careful when using it, and because there are also cross effects that have to be very well balanced. In the sense that our task as DSOs, of course, is firstly to facilitate, to provide access to our grids to the users. That's our grid is there for that. On top of that, we have to ensure also security of supply. So it's not like and you have to take into account that DSOs are as mentioned previously, we are some thousands of DSOs in Europe with different shapes and organizations. So it will be difficult to send the same messages for all of them if we don't have the clear rules, a clear understanding of what these flexible connection agreements could entail if not used in a proper way. We need to have a good assessment, and then I can understand why regulators choose this this priority in the list, and probably the market-based approach is probably I would say the easiest way to move forward and try to use flexibility without harming very much, and with using the existing knowledge on the field. So yeah, that is basically
cool. Judith, you mentioned before, or you highlighted that European regulation says, first of all, you should use market-based solutions.
That's how it is.
And so here a question. So we talked, I learned about the increase-decrease gaming, and somehow this was something that led us to, okay, maybe we don't have a good answer yet to this. So that also led to, okay, maybe that's more a question of the future. Maybe we are still in research phase to answer this question, some other questions for market-based flexibility markets. Do you have a perspective on that already?
A forming perspective. So there is definitely a risk of gaming in markets where the liquidity is low, and the market participants have information where the congestion will occur. There is a study on this, I think by Leon Hirth and co-authors, of the dangers of the increase-decrease gaming in zonal settings, and it is well known in Germany, and I think that's why they opted for Redispatch 2.0. However, as far as I'm aware, they are trying to improve this model by studies in how to evolve Redispatch to 3.0 so Redispatch 2.0 is obligatory participation, and Redispatch 3.0, or at least one project I'm familiar with, would be based on voluntary participation, and there would be a mix of these two concepts. When you reimburse flexibility in a cost-based manner, I think DNV's report results present that that's not incentive enough to act in a flexible manner. This is certainly an issue that has to be tackled. But for example, if there is not a pay-as-cleared model, but pay-as-bid, it also already decreases to some extent this danger. Also in the UK, the DNOs, when they assess whether they invest in grid or procure flexibility, use a common assessment tool, which was developed by the Energy Network Association. And some of the DNOs published during their tenders the threshold of the value of the flexibility that they are willing to pay, because above that threshold, they will automatically, in my understanding, switch to grid reinforcement. So this is also a way to keep the markets healthy, at least until there is more willingness to participation, more liquidity. So if a problem occurs with markets, maybe we shouldn't just discard the idea to have markets, but put effort in solving the issues around markets, because markets are at the stage when they are well functioning, a quite secure way to allocate price signals and communicate with the market, as is already observable in Great Britain. But yes, I beyond GoPax, I don't really know of any business as usual approaches. There is Nodes, but Nodes is a big platform for local initiatives. And there are many, not centralized, but DSO developed flexibility market initiatives. I think E.ON has some, because I know that in Hungary they have, and Enedis, I think, has local tenders as well. So they are doing the leading.
Yeah, great. So I see time is progressing, and I could continue this for a long time, but I think we soon need to look into our actually last round. So I find this very interesting. Also, the question that came from many of you actually, like, okay, we can use the non-firm connection agreements, and they really help in the short term. But then you mentioned, okay, there's maybe a limit. And as a certain limit, these all should decide to do grid reinforcement. So I think that's a very interesting optimization and also regulation question, how you get this right. But yeah, we have a couple of questions from the auditory, so let's have a last round actually. Combining here those two questions that I thought about. So yeah, basically, what is your recommendation? What needs to happen first? Either from this vicious circle perspective, which actor is the most important to act now? What is the right incentives? Is it financial or is it others that we need? And yeah, if you have a key ask on European level or on member state or on DSO level, then this is now the time for it. And yeah, Hans, before we ending with you again, maybe let's start with you this round, so you also get this chance.
Yeah, well, there are many elements, but let me focus on two I would like to address. First, I would like to put emphasis on the position of the customer, the end user, whether that's the industrial user or the residential They obviously have an important role to play here, the active customer, active consumer. That deserves attention also from, I would say, policymakers, from regulators, how to involve the customer. It's not only about incentives, it's also about communication. It's also about transparency. There's, of course, it was already mentioned, the need for DSOs to become more transparent on their needs, their flexibility needs. That is also something that has to improve quite a lot. But customers should be incentivized, be informed, be made enthusiastic to participate in any mechanism that is out there or that will be introduced, because they have a key role to play in optimizing the energy system, especially in the local grids. And the other element I would like to mention is indeed this ecosystem, where we see that often regulations are targeting one single actor, for example, the DSO, where it would be important to understand how all those actors are depending on each other, and so the report shows are to some extent waiting for each other. How can we now make sure that they will all move together in the right direction? And that is not an easy question or an easy answer, but I think especially from policy, that is something that should have more attention, with, as I said before, the pivotal role that the customer has in that ecosystem.
Great. Nomi, you want to take over?
So first of all, just to react to what has been said, I really agree with what has been said. We support flexible grid connections, or we really highlight the potential of simpler solutions like the connection grid tariffs, but also the user tariffs, so time of use tariffs, but also self-consumption, which is also in a way not a time of use tariff, but it's also using the network tariff, or collective self-consumption as well. So we really would like those solutions to be assessed and taken up by DSOs. This said, we also believe in the importance of having purely market-based solutions. And Solar Power Europe is a part of the drafting committee. Actually, we have a meeting as we speak with Acer, ENTSO-E, and EU DSO entity, and we shared a number of points. And it's true that we have this danger of only resorting to the simplest solutions, and we shouldn't do that. And I think that really highlights the importance of planning ahead at DSO level, and also planning with the regulators and with the political authorities, because it's such a big change for the DSO organizations, and it's so, in a way, risky, that we need a sort of regulatory but also political environment that says, yes, it's the direction that we take. I think, Hans, you mentioned it's not only about reliability, it's also about sustainability. So there might be trade-offs there, but this decision, it's not a technical decision, it's a political decision. So there needs to be also the policy level engaged. So what does it mean for the EU level? I mean, I'm always saying it's three things. It's better planning, so implementing the flexibility needs assessment methodology that we'll have at EU level. And there is a danger that this is made based on the tools that we know very well at EU level that are made for interconnections, like the ERA. So we need to tailor it also for DSOs. Once we have the planning, make price, develop a framework of price incentives, and there will be different incentives for different consumers. An office building has a different flexibility potential as a residential building, and it's the same for an industrial building. And a third point is that there is also an important role of standards, because behind all of what we're discussing, there is hardware, and my association represents also manufacturers of this hardware. And those producers, they need to have a clear view of the rules that they have to comply with in the 27 markets, because the alternative, I mean, now we're really in a race with the US, with China, but those are really big markets where you have almost one rule for the market. It's not exactly like that, but there's a strong alignment on standards, for example, when it comes to cybersecurity, to communication. So it's important to also regulate that. The issue, and I will conclude on that, is that DSOs are less tangible at European level than an interconnection in the North Sea. So we also need to think on how we make this tangible for policymakers, and that's why for us, any indicators of the situation on the ground would be very important. So that's why we having a EU map on grid hosting capacity at distribution level, or a grid connection queue at distribution level. They're doing that in the US, would be also very important, so that we keep being reminded that it's all part of one European grid challenge.
Very convincing. Thank you, Naomi. Santiago, I go over to you, and then we conclude with Judith. And then we still need 2 minutes or some minutes for questions from the auditory.
No, okay, very briefly. I mean, just I mean, to repeat some of the ideas. I mean, implementing regulation is the main thing. I mean, it's not that I think that we have to blame on regulators. No, of course, no. It's just because I mean national regulators come after all the process. I mean, we as DSOs we have to DSOs and stakeholders at the other party, we have to be confident in the way we can provide flexibility, we can use the new tools. And so this is a first technical step before saying that it is possible. And then, of course, there is the high-level policies and the European regulation, like the clean energy package with the distribution development plans, and also the use of the non-firm connection agreements, and then, of course, the network, the European Network Code on Demand Response. So this comes first, and then once we have this, then we have to go to the national level, implement terms and conditions, and the particular rules on that. So this is still needed. I mean, to have this national implementation, that, by the way, is really difficult, because we come from different national regulation. We have the different approaches in every jurisdiction, so it's difficult to do it, but it's a needed step. And of course, another thing is that I think we need the participation of not only of DSOs, or in this case, but also we have also other facilitators. I just want to mention two of them: energy communities, for example, and aggregators are really needed in this process, because the final customer, the household, is really difficult for them will be really difficult to participate. So also to incentivize this kind of roles will be also very helpful. Thanks.
Thank you. And Judith, please briefly the most important points to act.
Thank you. I have 6. Okay. First, just to very quickly reflect on. Yes, this is a policy goal, so we need support from the policymaker, target clarity and legal clarity in our mandates, what to enforce. Yes. Secondly, we need out their assets, because we need those customers, as all of you said, and we need to engage and educate them. But just from market signals, they won't install assets, so we need some direct support for EVs, for heat pumps, for batteries to be out there if we want to have residential flexibility. Also, I would have wanted to tell a few words about TOTEX and the TOTEX-like approach. So regulators realize that you need incentives, but of course we have to be aware what will be the distribution of the cost between flexibility and grid. And in this regard, the UK DNOs have stepped one step further and unbundled part of their network and flexibility procurement departments. So that is maybe also a possible aspect to consider. And in the end, my personal take would be it would be so nice to have a demand side flexibility potential assessment national on commercial, industrial and residential levels, so that we know which areas should we target first to be effective, because there are so many ways. And just one last thing, Regulatory Assistance Project is preparing an NRA toolbox for congestion management, and there it seems the best what all of you suggested, that it is not one tool, one solution, but a complex interacting system of solutions. Some of them counteract each other, some of them are prerequisites of each other, and this concerto of tools is what we need to prioritize. What should we build first, so that we can build the whole pyramid in good coordination and in good cooperation within all the stakeholders.
Thank you very much. Very impressive statements from each of you. Thank you so much. Looking at the auditory and the questions, so there's maybe a quick one to Santiago. To which extent you have already real-time active control and power management in the distributed power system, or using flexible loads today already?
I don't know the exact figure in that regard, but I think that we have, just to give some ideas, we have a third of secondary substations already automated. So, I mean, of course, the primary substation are already automated, but the secondary substations, we can control them. I mean, so it's already a lot, because, I mean, 10 years ago probably was just 1% of the assets. So this makes more control of our grid, and probably to use. Of course, we have. I mean, in the case of Spain, in Iberdrola and in Spain, we have 99% of smart meters. So we have a good observability of the grid, and now working. I mean, to give a full view, we are working now on having controllability also of the low voltage grid at certain points, because it's difficult to have all of them. It's very, distributed, but then we're working on having also controllability of the low voltage grid.
Thank you. And a question to Naomi. You mentioned cybersecurity, and a participant noted that the US is advancing actually on certification of distributed energy resources and the devices in respect to cybersecurity. Are you aware of what's happening outside Europe, and are we learning from each other, implementing similar standards so we can use the same products?
Yeah, absolutely. So yeah, cybersecurity, it's both rules on how products should be manufactured and what software goes in it, and it's an architectural responsibility between the operator of the infrastructure, the grid, etc. So on the second part, I think there is the NIS2 framework, there is the Network Code on Cybersecurity, and things are advancing. On the first part, in the security of product, yes, the US and Australia have advanced quite well. The US has a very interesting indeed standard for solar products, solar inverters. That has been developed. In Europe, we are subject to some regulations and the Cyber Resilience Act and the Radio Equipment Directive, but indeed we do not have a DER or even a solar specific standards. And this is actually something that we would like to have, because we do think that it's very important. So we should be issuing a position paper on that late in a couple of months, but we're already exchanging with Sensenelec about that.
Thank you so much. And with that, let me conclude this panel round. So thanks again for your great contribution and the questions that were posed. So we are about to close this call, and I will not comment on the statements you made. I think that's all very interesting and very relevant points. Maybe the most important one is actually that we all have to work together. And to get started, see where the barriers are and where collectively they can be overcome. What I would like to add is a reference to integrated system planning, which Agora is advocating for the European level, integrated electricity, gas, and potentially hydrogen network planning, which we advocate for the transmission level, and actually also could recommend for the DSO level that we actually need these. We need target plans. We need to know where the system is going to. Only when we have a target plan, we can discuss on it and discuss on what will be allocated where, and where is it more efficient to use a grid expansion, and where can we apply a temporary or permanent demand response or flexibility option. So that would be basically my ask. And Kaisa, are you still with us? So I would hand then to you, closing this panel, and I think you can tell us what happened in the meanwhile on our website and what people can read further if they're interested.
First of all, I'm still with you. Thank you very much from my side to our esteemed speakers and also very active audience. I hope you enjoyed it and learned a lot. I know I did. Indeed, and there was a question as well regarding this. The full study is available on our website. Maxi will be posting links to the chat. We have also written a blog post that includes Agora's conclusions and recommendations moving forward from here that is linked to this study. With that, I will also close from my side. Thank you again. Have a lovely day, and I hope to see you soon again.